In this example, you're being asked to do a bunch of different things. First off, they want you to sketch a graph of the second derivative. They want you to also determine the concavity of the original graph of your f of x graph and identify any inflection points that original graph might have. And the kicker on this is that we're not actually given the original graph. We are given the derivative graph. So we are given f prime of x. So what you're looking at over here, this is the graph of the derivative. This is not the graph of the original function f of x. So we cannot just read off of this graph the concavity. So we say to ourselves, well, how am I going to find the concavity? Well, concavity is a second derivative game. And so just remind yourself that if you are at the first derivative, to find the second derivative, you just need to take the first derivative, right? So if I take the derivative of f prime of x, I get out f double prime of x. So what that tells me is, in order to find my second derivative information, I need to read my derivative data off of my derivative graph. That's going to tell me second derivative data. So when you're going to read your derivative information off of a graph, this is all about what I call the derivative triangle. So if your graph is headed up and is increasing, then that's a positive derivative. If your graph is headed down and decreasing, well, then that's a negative derivative. If your graph is going horizontal at any point, that's a zero derivative. And so places where it goes horizontal, we refer to those as critical values usually, but they're maxes. They happen at mins. They also happen when your graph just goes sideways for a second. So in order to find our second derivative information so that we can find out the concavity as well as graph our second derivative, we need to read the first derivative off of this given graph. So we're going to read the derivative off of our derivative. So just like you would if this was the original graph, this is all headed up. This is all positive, 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 positive. That's all heading up. We get to the very top there. It goes horizontal for a second, so it goes to a zero. Then coming out of there, this is all negative, 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 headed down. Then at the bottom, we get ourselves another zero. And then from there, we're headed up. So positive, 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 positive. So all those positives, negatives, and zeros, that is second derivative data right there. So if we wanted to sketch our graph of the second derivative, I'm just going to put it down below here. Sometimes they want you to do it up above, but I'm just going to, for the sake of making everything visually easier to see, we're going to graph down here. So we are graphing this information, this first derivative information is going to give us our second derivative data. So when you do this, remember wherever it was positive, that's going to go above the x-axis. Wherever that slope was negative, that's going to go below the x-axis. And whenever that slope was zero, that's going to go on the x-axis. I always start with the zeros. The zeros are going to be the easiest thing to graph because you know where they're happening at. So at x equals -2, I know my value there, my slope was 0. So I just come and put that right here. I know also at +2. I had a slope of 0. And so I put that right there. So I put a dot on the graph right at 0. Those critical values, those zeros, are always going to be the easiest thing to start on when you're graphing. After that, you're going to come through and you're going to work left to right. So to the left of -2, all this stuff over here, I'm going up. I'm in the positive and I'm increasing. And I start from a very steep slope. The slope of this graph is steep. Say something like an m equals 15. So when you're sketching it, you want to start wherever it starts. So this would start steep. And as we head up here, this graph is just going to be getting flatter and flatter. You know, in my head, I'm like, okay, that's a slope of 1. So I start steep and I head to flat, ending at that 0 that I know has to be there. then in between my two critical values, in between my two zeros right there, I'm all in the negative. This time though, I'm going to start flat. So like an m equals -1. It gets steep in the middle here. So maybe like an m equals -10. And then again, at the very bottom, we're going to get flat again, heading into that 0. So we're going to head back to like an m equals -1. Those slope numbers, I'm just making up. You just need something to give yourself a point of reference. So flat, steep. So we start flat. It gets steepest in the middle, and then we got to turn back and head towards that 0 as it gets flat again. Now we look to the right of that 0, and we can see that this section is going to start flat, and it is going to end steep. So we start flat, and we end steep. And so what you're looking at down below here, this is now a sketch of the second derivative. You read the derivative of your first derivative graph to find your second derivative information. And so now what you can do is you can come back and answer more of their questions. So they want us to determine the concavity of the graph. Okay, well, things are either concave up like a cup, and that is where our second derivative is positive. Things can be concave down like a frown, and that is when our second derivative is negative. And then the place where they change concavity, so say it stops being concave down and starts being concave up, or it stops being concave up and starts being concave down, those places right there where the concavity is changing, those are our inflection points. So inflection points have to have two properties. They happen when our second derivative equals 0, or like we saw with critical values, our second derivative is undefined. That's the first thing they have to do, but the second thing they also need is they must change concavity. So you have to have it change concavity at that point. So positive concavity into negative concavity, concave down into concave up, or concave up into concave down. So let's go back and give them out their answer. So we are looking for the concavity of our graph. So to the left here, we're reading off of this graph. All of that positive stuff, that is positive second derivative information. And so that is when our graph is concave up. So we would say starting at negative infinity and then ending at that value right there, -2. And then we don't include -2 because it's not concave up or concave down there. So you want a parenthesis and not a bracket in that situation. And then you would put a union symbol because it's also concave. Thanks for watching my video. If you liked it, please click that like button and subscribe. And also share it with your friends and anyone else you know who might be crying about an upcoming AP Calc test. You can find more videos from me, more sample AP Calc questions, and my complete AP Calc study guide over at my website, apcalcprep.com. Have a great one.